In this video, we will demonstrate the first way to find the time constant for a circuit which has a capacitor or inductor in it and which suddenly changes. The basic action that we are to take is to determine what the Thevenin resistance is across the terminals of the capacitor or inductor after t equals 0. After t equals 0, our initial circuit looks like this. To find the Thevenin resistance, we short the voltage sources and break the current sources. There are a voltage source, so we just short it to get a 10 ohm resistor and a 20 ohm resistor, and then these are terminals A and B. Now, to get the Thevenin resistance, we follow the circuit starting at A. Starting at A, we reach a branch that goes to the 10 ohm and the 20 ohm in parallel, so we must simply add these two resistors together in parallel to get 200 over 30, which is 20 over 3 ohms, and this is the Thevenin resistance. So we've determined the Thevenin resistance for this circuit. Now, it doesn't matter if this was a capacitor or an inductor, we would still need to be looking for the Thevenin resistance across the terminals of the capacitor or the inductor. Now, determining the time constant tau is very simple. For a capacitor, it is R Thevenin times C. Or for an inductor, it is L over R Thevenin. Now, for this circuit, we know that C is 1/4 farads. So the time constant is R Thevenin, 20 over 3. So the time constant is R Thevenin, 20 over 3 times 1/4 farads. And this is equal to 5 over 3 seconds. Now we can finally fill in the original equation in total with tau included. The equation is Vc infinity minus Vc naught times e to the negative t over tau. So this is equal to 20 minus 10 e to the negative t over tau, which is 20 minus 10 e to the negative t over 5 over 3, which we'll flip the fraction to be 20 minus 10 e to the negative 3t over 5. Way number 2 is a bit more complicated. For basic first-order circuits with a single inductor or a single capacitor, this method with R Thevenin will always work. But I will be uploading another video with way 2, and the techniques that we discuss in that video will be helpful for more complicated future circuits that may have 2 inductors or 2 capacitors. However, on account of my being incredibly tired, that way 2 video will not be uploaded on this day. That is the day of this recording. I do highly suggest that you try a problem with an inductor just so that you get a feel for determining the steady state currents of an inductor before t equals 0 and after t equals 0. To this end, I suggest that you could look through example 7.12 in the book, which is on page 280. That's example 7.12, page 280. And of course, practice problem 7.12 on that same page, and example 7.2. Really, all the examples starting at page 280 are quite good and interesting.